Okay, we're going to start looking at how to differentiate functions and using this rule, the product rule, which is basically just a case of where you've got equations like it says up here of the form y equals f of x times g of x. So this method enables you to deal with expressions that are a multiplication of two other variable functions, i.e. to the form of f of x or g of x. So there's the basic theorem. If you've got a function which is made up of f of x times g of x, then the derivative of that function is given by f of x times g dash of x plus f dash of x times g of x. This is the you do, you don't, plus you don't, you do rule, which we might have talked about before. Okay, for convenience, f of x and g of x are simply written as f and g. The product rule only need be used when f and g of x are two distinct functions being multiplied together. Okay, so let's have a look at a few examples of how these. So if you have a look at that, you could definitely use the product rule there. But they're saying you could expand it first and use the basic polynomial rules. You could do that. Or you could do it as a product rule. You'd call this one G and this one F. This one here, definitely you could use the product rule. You can't expand that out. You have one is equal to the function 2x and the other is x cubed, the square root of x cubed minus 5. So you definitely use the product rule for that one. This one here, you could expand it all out. It'd be pretty bit of a pain, but there you could use it as 4x, and this one is x squared plus 1 to the 5th. So you use the product rule there. The last one, yeah, definitely use the product there. Oh no, you wouldn't, sorry, because that's just saying you no need to, because that's just a 4. It's not a 4x, because to differentiate a constant just gives you 0 anyway. And the last one, yep, definitely use the product rule there. You wouldn't want to expand that out. With 4 brackets, the 6 brackets there, you'd use the product rule instead. Okay, so what's it saying? They're invisible signs. Okay, yeah, okay. Let's have a look at some examples. Differentiate y equals x minus 1 times x squared plus 1 using the product rule. So f equals x minus 1 and g equals x squared plus 1. Okay, so we differentiate each of these and set it out as follows. So f equals x minus 1. So f dash equals 1 using our rule of ax to the n to the n. The derivative of that is nax to the n minus 1. G is x squared plus 1, so g dash is just 2x. So using this is our product rule. dy by dx equals f times g plus f dash times g. We're going to end up with that. Okay, and if you probably expand that out, it's going to come down to that. Now we could have expanded those brackets out and just used the polynomial rules that we've had, but we can just do it like that anyway. Let's see if we have another example. Okay, yeah, this is what I was saying there. Just mentioning it would be easy, could have been easier to expand the brackets, but we did it that way just for the example. Okay, we're going to differentiate this one. Okay, now we're going to have to use the chain rule here. So that's from another video. We're going to deal with the chain rule. This is just the product rule, but we'll just using the chain rule. You can see that if f equals 3x take 1 to the 5th, f dash will be 15 3x take 1 to the 4th. G is x squared minus 2 or cubed, and g dash therefore is that. So once again, we just use this is our differentiation rule for a product that is where y equals f times g, where this would be our f, this whole function here, and this would be our g. Okay, so we just go, therefore it's f times g dash, there's f, there's g dash, plus f dash, there's f dash, times g, and there's g. So we're going to wind up with all that. It's still pretty messy, And we'll end up, it'll probably simplify to that. And we can leave it at that. We're not going to expand all those brackets. It's just too painful. Okay, we'll just try one more example. Oh, well, they're actually going to try and factorize that. This is not something we do. I'd be happy to leave the function looking like that. Okay, that's all you really need to know about the product rule at this stage. The next video will be on the chain rule.